everyone, and welcome to class. You have a great week so far. Good. Yes, I'm really. Are you sleeping? A bit. Okay. So, this week is, I think this session will be the last session on data modeling part. We finish with the normalization. Starting next week, we move to the next topic. And for that, as I mentioned before, you have the option to work with any behaviors that you like. But keep in mind that you have to at least know all the syntaxes that I'm using in my slides, for example, for SQL Server. So for this class, we're using SQL Server. I use it on the cloud, Azure Cloud Services. You have this option. You can use Amazon services or anything like that, or you can install it locally on your computer, right? That doesn't matter. If you don't have space, and I always find it easier to work with cloud services, so I work with Azure, and then I can help you. If you work it fast, then I can help you with the installation and next session. But just like give you a heads up to maybe go over the installation and everything this weekend before the next session. So next session, if you have any questions, you can ask me, and then we can start like hands-on session. So about normalization. And one more thing, because I realized the recording didn't work out last session. I'm not sure why. There were some technical issues here Tuesday, and it seems that the recording didn't work. I think that is working. I don't see any issue here, and so I'm going to just do it to the normalization. So for those of you who attend the class or missing the class, what is normalization? There is some like strong correlation between people who sit like in the first like 2 or 3 rows and raise their hands up for the questions. I don't know why.
It's like when you change a table that mask with a lot of identity, you change them to have only one primary key and dependency.
Can you speak a bit louder? Oh, sorry, like it's my hearing.
So if you get a table that's masked with a lot of information, you want to separate them to have unique identity, unique primary key, and you want to put them into separate tables based on their identity, and you link them through the foreign key.
Yeah, so breaking down the, like let's say you have a large missing table, right? Information about like different entities. We want to like break down that into smaller tables that are more organized. And the whole point is you want to this will help to reduce redundancy and maintain like integrity control, which we talk a lot about this concept in this class. And so you can think of it as maybe even like cleaning like your closet, right? Instead of like putting everything like disorganized there, you want to like categorize them so you can better find each like clothes, shoes, whatever that you want. Or for example, think about like hospital. If you want to like keep all like the patients, doctor, and all the visit information. So everything, let's say, in one file or one place, what would be the problem? Here, repeat. So let's say you are, for example, we are talking about hospital. Okay? So if you want to like, if you put everything, let's say, in one table or one file, it contains like patient information, doctor's information, all the visit information and everything, procedures, treatment. So what could be the problem with that?
If you want to change like a doctor's email, for example, you'd have to go through every single time to look at the email, change every instance. There'd be a chance where if somebody changes their doctor, that might be the only instance where the doctor is in existence, so now he's just cut out.
Yeah, so you may have like, for example, each doctor may visit a lot of patients, right? Doing a lot of different procedures. So every time that you want to update like just one small thing, like let's say doctor's email or anything, then you have to update a lot of places. And that's only one issue. So we talked about different things. But just to keep in mind why we need normalization, you can think of it as a way to reduce redundancy and keep our tables like more organized, right? So it's the process of organizing data in relational database to minimize redundancy and ensure data integrity, right? So that, for example, if you want to, for example, insert a new course, even if there is no student enrolled in that course, you would still be able to keep that course in your database until some student enrolled, right? Or, for example, you want to add a new department, right? So you won't have any issues because you're keeping things separate. You are keeping, for example, course information in the course table, student information in the student table, and so on. And so we break down a large unorganized table into a smaller related table. So we have several normal forms, but for this class and most cases, we keep up to third normal form. And today I'm going also to discuss why we may not want to like normalize, strictly normalize our tables to, let's say, 4.5, 5.5, and more. So that is discussion I can after that. We talked about 3 anomalies, and by anomalies I mean just what your friend described, right? The problems that we may have later if we just put everything in one table. Now, for example, we may have insertion anomalies, meaning we cannot add a record. Record means a row, right? Row of your table because of a missing value for one or more fields. And this happens if you are having by one or more fields, we mean those unrelated fields in that table. For example, keeping student information in the course table. Okay. Deletion anomalies is deleting of a record, causing an unintended deletion of information. Like, for example, when you delete a student, and then you will end up deleting the instructor information as well, right? Or department information as well. And then we have update anomalies, as your friend mentioned, and you have to update several places, and that's the minimum issue. Sometimes you may want to like manually insert or update something. If, let's say, you have like Dr. Brown with a space and then you forget the space, or there is a type or like something like small, and then there is inconsistency. If you have like this repeated in several like places, right? Then and you forget like to update it in other places, then you have inconsistent data in your tables. So here was just one small example with this small table just having 3 rows. So we start with, for example, insert anomalies, okay? So let's say, for example, you want to insert a new course like 4412, and this is, for example, one small example of insertion anomaly, that because you cannot add a new record, right? Because you have not any, for example, a student enrolled in that course yet. And then we had an example of, I think, update anomalies, no, deletion anomalies. For example, let's say if all the students drop a course, like for example the database, okay, then we lose all the course and instructor information as well. What was the problem here? This is easy, right? Yeah.
it's an update anomaly. So if Dr. Brown changes copies to model 5, you would have to change it in every single place.
Yeah, and then as I mentioned, that's the minimum issue that we have, right? If you, in case of manual, let's say updating, if you have also like let's say typo or something, then you have also inconsistency. Somewhere you have that typo, let's say Dr. Brown without space or with space, and then it causes inconsistencies. Now, how to prevent anomalies? Using normalization. And what do we mean by that? As I mentioned at the beginning of the class, I mean breaking down that large list table where you store like student, course, department, all information all in one place. We want to break it down into separate tables. Now, the only thing that we have to, the only, cannot say even tricky, and the only important point here is to know how to break down these tables. From where, right? Which, for example, columns in the student table, which ones in the course table, and so on. In general, we try to assign a separate table to each entity. So if you did a good job learning the ER model and data modeling part, if you did a good job understanding how to design your model, for what, for example, things or objects you need an entity, right? Then this is easy. Then you just convert each entity to a table. Now, here, the problem with the table on top, so everyone should be able to say the problem with the table on top. Yeah, it's a table that can be used for using multiple entities. Yeah, storing multiple unrelated information which are for different entities such as a student, course, instructor in one table. Now, how can we get rid of the problem with this table? Separating it into how many tables? 3, right? The reason that you see 2 here is because I just didn't have enough space, but into 3. So the course, instructor, and student tables, right? Now here you can see, for example, a course table and then instructor table. So why do we have instructor ID in the course table? If this is the course table, why do we keep instructor ID?
As a foreign key to link the two.
Yeah, so we still need a foreign key to link tables. So when you break down the your larger table, which is the messy unorganized table, let's say into 2 tables, here, you want to keep all information relevant to each entity in a separate table. For example, course information in the course table, instructor information in the instructor table. But because they have a relationship, right? You have to show that relationship. How? Using foreign keys, right? So why did we add foreign keys here? Why did you add the foreign keys here? Yeah.
To relate the 2 tables.
Yeah. So no, why did we add instructor ID to the course table? Because this is on the menu, side, right? And now in this example, which we reviewed last week, again there were several problems here. I put at least one example of all 3 anomalies in this table. So give me an example of, for example, insert anomalies. Yeah.
The last one, you can't insert the biology department because there's no student and advisor.
Yeah, we can have insert a new department. Let's say you want to you build a new department in your university, and then you cannot add it to your database because then you have lots of missing values, right? There are no, for example, students or advisors there yet. And so that was one issue. Give me a problem with the deletion anomaly. Yes.
If you delete Marino, then all the information gets lost.
If we delete what?
Marino?
Yeah. So if we delete Marino here, right? So he is actually the only student working with this advisor, right? So if you delete, let's say this row, this student, then you will lose like instructor information such as instructor email as well, right? Now give me an update anomaly.
So if the advisor changes their email, yeah, the update for everything.
Yeah, so let's say one advisor advise multiple students. If you want to advise, let's say that advisor's email, then you have to update it every time that you repeated that for each student, right? So these are the problems that we have. For example, if Matthew changes to the advisor, then we have to update his advisor email as well, or several other problems, like the example I mentioned. If you delete a student, for example, this one, which is the only student of this advisor, then you will use advisor information. And then you cannot insert a new department, like for example, biology department, because we have lots of missing information. And here you can see the normalized version. So, you know, if you want to normalize this table, you have to break it down into smaller tables. To which tables? As I said, we try to keep a separate table for each entity, right? And by entity, we mean like things, objects, places, whatever that we want to keep track of in our database, right? Whatever we want to store some information about them. Like for example, we want to store a student information. So let's say a separate table for a student. We want to have advisor information, like advisor name, email, advisor ID, and so on. So, and we may also have department table to store department information. So this will be the result. So now, I apologize for the poor quality. This is the department table, this is the advisor table, and this is the student table. So in the department table, we have department name, phone number, and the admin last name, first name, and so on. In the advisor email, the same. We have advisor, first name, last name, etc. And then the student information. Now, the better way here was that if we had department ID, something like that for the department table as the primary, because we try to avoid having choosing columns that contain non-numerical or non-integer non-integer values as primaries, right? So you try to avoid choosing your primary key based on a column that has, for example, textual values, right? Or not. That I gave you an example already, right? I said even if you're working on a very small table, let's say student table, right? And we say, okay, this is a very small database, and I'm 100% sure that no two students have the same name, so I choose a student name as the primary. Okay, so it may not have like a problem technically, but in practice, it may cause issues, right? We don't do that because what was one of the problems with this? Choosing, let's say, student name, advisor name, department name as the primary key. Someone else. You guys here? Anyone? This part of the class. So, yes.
Names could be too long, so once we change that, it's gonna be hard.
Names could get long, and it might be it will be more difficult for indexing or later because primary keys by default are indexed. And then you want to, for example, join tables later, which will be way more difficult using textual primary keys. That's one issue. Another issue is
like name, like is not something, it couldn't be unique, for example. Like it has to be something, a student number is always unique to someone, but name, we can have 5 Mohammed, we can have 5 Alex, we can have even the same last names, you never know. So
yeah.
That's why it could cause issues later.
Yeah, even if you don't have like 2 similar names currently in your database, you may like insert a new student, like maybe tomorrow another student will in the class with the same name as another student, right? So that is not a guarantee that you will not have two similar names, same names. So it's better to use like something like, for example, a student number, employee number, something like that. And we often have that for like our main entities. If not, then I explained, as I explained before, we may, for example, want to use composite entities, right? For example, for a table like enrollment, right? Sometimes, composite primary keys. We may want to use a combination of columns as a primary key, or using a surrogate key, which we have some examples in these slides. And then we talk about dependencies. So we said we have three normal forms: 1NF, 2NF, 3NF, and then so we have, I'm not sure which part is recorded. So I have here and this one. Okay. So we have 1NF, right? And then 2NF, 3NF, BCNF, 4NF, 5NF, okay, but we don't mind them for now. We only care about like up to third normal form. So first normal form, and for these, I have some definitions, right? For example, we say table is in first normal form if, how do you know a table is in first normal form?
When there are no multiple values in one column and no repeated rows. When there is no multiple values in
Yeah, when we have atomic values, there are no multiple values stored in one cell, or let's say we do not have repeated groups for each row. I'm going to explain that what I mean by repeated groups, not necessarily the same things repeating. Basically, you only care about multiple values stored in one cell, okay? If you see that, that table is not in first normal form. So let's say you have a student here. So this is one problem, right? So you have the student table with, let's say, student ID, name, and then let's say course ID, name, and so on, and maybe even having instructor information here. So several problems about keeping everything in one table. First, one student may take multiple courses, which means we have, for example, I may take a database course here, 3421, I may take 3401, I may take 4412, right? This is what I mean by repeating groups, right? This is for each student, we are storing multiple rows, multiple courses, right? And so we don't want that. It basically means storing multiple values in one cell, which we don't want. So you have different ways to address it. If you want to stick to keeping things in one table. Now, this is a very obvious example, especially because we use this frequently in this class. But like in future, when you are like not confident, you can work several ways. So for example, you say, okay, oh, now I have multiple values, and you don't know if you have to consider it, store these values in adding more columns to your current tables, which could be the case sometimes. For example, let's say you only have cell phone, or for example, home phone number, right? Then you may want to consider adding like new columns, right? One column for storing mobile phone number, one column storing, for example, home phone number, instead of having multiple values for phone number here. And so that is one case. Another case is considering a separate table to store phone numbers, right? So if you want to know what you have to do, that is one way, adding new columns, or separate them into new rows. So I will show you what is the problem with both ways in this case, and why we need to normalize it and break it down into separate tables. So let's say, for example, here, if we want to, instead of storing like this, that are multiple values stored in one cell, I say, oh, I put them in separate rows, right? So for example, now I have this row, and then this row, then you will end up probably with defining your primary key, right? Because then we have several keys, instructor ID, course ID, student ID, and then you have to get like you have to collect several columns to form a composite primary key, and that's only one issue. There are also anomalies that we discussed, right? User anomalies, object anomalies, and so on. And this is also not possible to add like each course as a separate column, right? That's not feasible. So you have no way, you have no other option. You have to create a separate table for course, right? You cannot store them like maybe 100 courses in separate columns, or like continue like this with having no primary keys and several anomalies. So we say, okay, let's break it down into student table, and then course table, and then instructor table, right? This is for student, this is for course, this is for instructor. Now, we say table is in 1NF if you don't have such issues. That is, if you don't have multiple values stored in cell, or they are atomic. So I just write atomic values. No multiple values stored in one cell. Now, 2NF. For what was 2NF? What is 2NF? Second normal form? Yep, the end of the class, yes.
It's already in first normal form, it has no partial dependency.
No partial dependency, right? And also being in first normal form, so be careful. Because you always have to check the previous one. So 1NF being in 1NF plus no partial dependency. Okay. So this table is not even in 1NF, so it cannot be in 1NF, right? And then 3NF, which we didn't discuss yet, means the table is already in 2NF, means the table is in 1NF, 2NF, right? Plus no transitive dependency. Now, in order to understand these normal forms, we have to understand the functional dependencies, right? Because you have to know what is partial dependency, what is transitive dependency, and in general, what do I mean when I'm talking about dependency? So dependency means we have, for example, this relation or table. By relation, we mean in relation to databases, we mean like this table, right? We have this relation R, right, which has a column or attribute X that can uniquely identify another column, non-key column in the same table or relation. So the same relation, another column which is Y, right? Now, we have different types of dependency. We have full key dependency. We have partial dependency, and we have transitive dependency. So for the first two types, both full key dependency and partial, the dependency is between one non-key column and your primary. Okay, so if full key dependency. Then partial dependency, and then I explain transitive. So, what is a full key dependency? Let's say you have a table, a student, with a student ID, a student name, first name, last name, phone, email, and so on. So, I give you this table and I ask you what normal form is this table. And let's say we have this. let's say 1, 2, 3, and something, and assuming that we have no repeated, rows, we do not have multiple values stored in one cell. If we do not have multiple values in one cell, or let's say all values are atomic, then it is in one, right? Now, in order to understand if this table is in 2NF, what do? Check for partial dependency, right? Now, you have to see if there is partial dependency or not. If there is no partial dependency, then you can say that the table is in 2NF. Now, how can I check the partial dependency? So, always check for primary keys, right? What is the primary key here? Student ID, right? This is your primary key. Now, for all functional dependencies, like the first two full key and partial dependency, the first thing you do to identify the normal form and functional dependencies, you check the primary key. Now, if you have a single primary key, can we have a partial dependency? No, because by definition, we said what is partial dependency when a column, the non-key column in your table, depends on only part of your primary key. Let's say you are in enrollment, something like an enrollment table, right? And then you have a student ID, right? Course ID. And we, like in the most normal form, the enrollment table should only have a student ID, course ID, something like grade, right? Not something that depends on these. Now, let's say I put, for example, a student's name or course title here. Course name, and then grade here. Now, the table, assuming is in 1NF, that means we don't have multiple values in one cell. We want to check if it is in 2NF or not. For 2NF, we have to check the partial dependency. Partial dependency means a column depends on only one part of your primary key. Now, let's say the primary key here is a student ID and course ID. We know that, right? We know that this enrollment table, it wasn't associated edit, right? Which is connected to both course and student tables, which means taking those primary keys from the student table and course table as foreign keys here. So each of them alone are foreign keys here, but together they form your composite primary key. Now, if we have composite primary key, can I say the table is in 2NF? Not necessarily. If you have composite primary key, the only thing that I can tell you is that please search for partial dependencies. You may find it or may not. Depends. For example, now we have composite primary key and we have partial dependency. Why? Because now a student name, right, only depends on a student ID, and course title only depends on course ID. What do I mean by dependency? What do I mean when I say a student ID can uniquely identify a student name, or a student name depends on a student ID? What do I mean by that? Yes?
You're not using the other primary key in order to help you get the value, or so it's like they're just not.
That is why we say we have partial dependency, because this, for example, a student name only depends on a student ID for its definition and not on course ID. So this is our primary key, right? A student ID and course ID is your primary key. Now we have a student name. A student ID can identify a student name, right? What do I mean by this? If I give you a student number, you can tell me what is the student, right? Which means this student ID can uniquely identify student name. Now, can I say course ID, a student name? Can I say student name depends on course ID as well? No, because if I tell you 3, 4, 2, 1, you cannot tell me one student, right? There is no one student assigned, like can be identified by this course ID. The only thing that you can tell me, if I tell you, let's say 3, 4, 2, 1, you can tell me the name of the course, right? So with course ID, you can just tell me what is the name of the course. So this is the meaning of dependence. So when we talk about dependency, when I say a student's name depends on a student ID, or there are two ways to read this. Let's not get confused because I see students sometimes get confused. So in order to read this, either you have to say a student name depends on a student ID, or a student ID can uniquely identify student name. Okay. Now, back to our example, we said that this table is not in 2NF because there are partial dependencies, right? And what is partial dependency? You should have a composite primary key, right? There is no way with single primary key having a partial dependency, right? Because you should find a column that depends on only one part of primary key, and primary key is only one. So all dependencies here are either full key or transitive. Now, so is partial dependency clear? Okay, if that's clear, let's go back here. Now in this table, is it in 2NF? Everyone. Is it in 2NF? Yes, it's in 2NF because you don't have a composite primary key. If your primary key is single, it means you have no partial dependency. So this condition is okay, right? And the table is already 1NF because I said that our assumption is we don't have any multiple values in one cell. So we have atomic values. So the condition for 1NF is also okay. So the table is 2NF, right? Now, what is a full key dependency? I give you the definition, you tell me the example, okay? So full key dependency means you have one or more columns. You find a column that depends on the entire part of your primary key, all part of your primary key. Now, give me an example of full key dependency. So instead of finding a column like, for example, a student name that only depends on a student ID, which is partial dependency, or course title, which only depends on course ID, right? We want to find a column that depends on all part of your primary. What is that? Yes? Great. Great. Yeah? Great. So actually, great depends on all part of your primary key, right? Because giving a student ID alone, you cannot identify the grade, right? So you cannot write this. Course, the same, right? Having the course, let's say I tell you 3421, can you tell me the grade? No, it depends on what student you're talking about, right? So a student ID and course ID together can uniquely identify each grade. Because if I tell you, okay, this student, specific student, let's say Mona, on 3421, the course 3421, then you can tell me what is my grade on this course. So this is an example of a full key dependency. How about here? Can you give me an example of a full key dependency? Do we have a full key dependency here? I really love how you say no. What is the definition of full key dependency? You have a column, depends on all part of your primary. So, for example, a student ID can uniquely identify a student name. Do we have this dependency or not? We have. A student ID can uniquely identify, for example, a student first name, last name, phone, and so on. So basically, in a table, in a normalized table with like single primary key, all columns, all non-key columns depend on the primary key. Because what is the definition of primary key? Primary key can uniquely identify each row, right? Which means a student ID can uniquely identify student name, right? A student ID can uniquely identify first name, last name, and so on. Okay, this is clear? So this is a full key dependency. Now, what is a transitive dependency? It's all about non-key column. So when I'm talking about non-key column, I mean non-primary key, okay? So it's dependency between non-key columns. So for instance, in let's say in this table, I add advisor, right? Advisor ID, advisor name, and office name. Now, can I say advisor ID can uniquely identify advisor name? Yes. Can I consider it a full key dependency? Yes. Why?
Uniquely identify.
If something uniquely identifies something else, a column uniquely identifies another column, does it mean that it is a full key dependency? Full key, the name says full key dependency, right? Means a column depends on all of your primary key. Now, if it is a single primary key, this is an example, right? Name depends completely on primary key, and this is only one column. Or, for example, grade here, in this example, grade depends on both the student ID and course ID, which means you have a column that is grade depending on all part of your primary key, which is the student ID and course ID, right? So this is a full key dependency between a non-key column depending on all part of your primary keys. Now, is advisor ID primary key here? No, it's a foreign key, right? So we say when we say non-key, and I mentioned I mean non-primary key, that's what I mean. So you have dependency between advisor ID name or advisor ID in office, right? It's office location. This is an example of transitive dependency, okay? And it means the table is not in 3NF. Yes.
So is the column has to be like that's the one related to the other one, or like what do you call the full key? Is it the grade or the student ID?
It's dependency. Both, like it means this column depends on the whole part of your primary, right? So this means so this is an example of a full key dependency. Okay. Now this table here, this enrollment table here, is only in one NF. Why? Because we don't have multiple values stored in one cell. That was my assumption, right? And then, so we know, knowing that or assuming that the table is already in one NF, we said, is it in 2 NF? No, because we have partial dependency, because we have a student name that depends on only a student ID. Also, we have course name that only depends on course ID. So these two are examples of partial dependency. This is an example of a full key dependency because now grade depends on all part of your primary key. So this is also an example of full key. Here, a student ID can uniquely identify student name. So if I write a student ID, student name for this table, so if I write this for this table, here it is a full key dependency, right? Because now your key is only student ID and you have a student name that depends on the whole primary key. So in such tables, so all these are, for example, email, the student ID. So this is a full key dependency. Now, transitive dependency is between non-key columns. So you have a column like advisor name that depends on advisor ID, right? But advisor ID is not a primary key, okay? Now, so I have to agree. So let's see more examples. So here is just the example that I mentioned. So we have, for example, a student ID uniquely identifying a student name, course ID uniquely identifying course title. Now, a student ID, course ID, can we have like this dependency? Is this correct? So you see like this third line here, a student ID, course ID. Is there a dependency between a student ID and course ID? No. Okay. So if I tell you, for example, the student ID, you cannot identify the course, right? If I give you the course title, can you identify the student name? No. You cannot uniquely identify student name. A student ID grade? No. Right? grade cannot be uniquely identified by a student ID. It's not unique, right? For each student, we may have several grades, right? It's not like if I tell you, okay, this is student number, and you tell me, okay, it's, for example, 85% is grade. So the grade on which course, right? So this is also not correct. Course ID grade, if I tell you a course ID like 3421, can you uniquely identify grade? Can you come up with only one grade? No. We have several grades for different students, so this is also not correct. Now, this is what I explained about normal forms, first normal form, second normal form. So we already had this example. This is the same as what I discussed here, right? So the table on top, is it in 1NF? No, right? We have multiple values stored in the cell. So we separate it into two tables. And so we now store, like, for example, the student information in one table, and then here we have something like enrollment table, right? This is not still in like 3NF. Now, what is the normal form of this table? The one on the bottom right, this table. In order to identify the normal form, where do you start? First, check for 1NF. Is it 1NF? The table on the bottom right? Yes, it's 1NF. We don't have multiple values in one cell. All are atomic, so 1NF. Is it in 2NF?
No.
No. We have composite primary key, so we have to check for partial dependency. Now, because we have course title, which depends on only part of your primary key, right? We have partial dependency. So the table is not in 2NF. Now, if we didn't have course title here, let's say we had a student ID, course ID, then instructor name, instructor location. What would be the normal form then? Let's say I have a student ID, a student name, advisor or instructor ID, and advisor or instructor name or office. And sorry, also the course ID. We also have the course ID. So I removed the course title here. So if we have a student ID, course ID, instructor name, and location, what would be the normal form?
One and a?
So it is already in 1NF, but is it 2NF or not?
No, because the course ID is still part of the composite key and student name normalizes the student ID.
So if we have, I said if we have this. So right now what you see on the bottom right, so this table on the bottom right, there is a composite primary key, right? The composite primary key is a student ID and course ID. And there is a partial dependency, right? What is that? Course title depends on only course ID. So there is partial dependency. So we know this table is not in 2NF. Now what I'm asking you, if it was a student ID, course ID, right? So I remove course title. Now I only have instructor ID and instructor location. So in this case, and let's say this is my composite primary. Yeah.
It's in 2NF, but not in 3NF.
2NF, but not in 3NF, right? Now it is in 2NF because we removed the partial dependency, right? The partial dependency was between course title and course ID. So if you remove the course title from the table, it means the table is in 2NF, right? Now you have to check for other dependencies like transitive dependency.
Is the instructor name and instructor location linked to a course or no? Because it looked like
The one in the bottom right?
Yeah.
Okay.
like is the instructor name and instructor location linked to a course ID or not for this example?
You mean while linking, you mean the dependency or
Yeah,
talking about
because
the
it
dependency?
just looked like it repeated, so I wasn't too sure.
No, you don't. Okay. In order to find the dependency, you only have to check, for example, if for example, let's say if giving you a student ID, you can uniquely identify a student name, right? If I tell you, for example, can you say, if I give you a student ID, can you tell me what is the instructor name? No, okay? So this is how you have to check for dependency, right? Now here in this table, this specific one, we had partial dependency between course title and course ID, which I said if you remove course title, we end up with a table that is into enough, right? I think we may have it later. So this is only like emphasizing this slide, the fact that we have composite primary key here, right? Now, and this is the same. So you see student course here. This is same as enrollment. So you have like this biggest student report table. The reason I mentioned report here, because this is not actual like table in 3NF. So it's like a report, you put everything there. Like a student information, course information, instructor information, right? And then if you want to normalize it, instead we have to break it down into smaller tables, each table focusing on a specific entity, right? For instance, instead of having a student report including all those information, now I have a student, only student information, and then I have a student course, which is similar to enrollment, right? Now, in this table, we have, let's say, a student ID, course title, which was not 2NF, right? Because of the dependency between course title and course ID. Now, let's further normalize this. So this is just the definition of second normal form that you already know. And this is just showing how we show these dependencies that I already showed you, right? This is how we show these dependencies. Now, okay, so we are continuing from like the previous slide, right? So we came from here, so this table here on the bottom right, right? Now we want to further normalize this one. So we normalize the one on top. We broke it down into like these two tables. Now because this one is also not in 2NF, right? We have to still break down the table. So before I move to the next slide, can you tell me how do you break it down to normalize it? How do you normalize this table, the one in the bottom right? Yes?
You could separate it based on the entities, so like one for student, one for course, and another one for instructor.
Yeah, and another way to remember this, to break down the dependencies. So to normalize table, you find the dependencies, you break it down. Same thing that I did here. So I said we have a student ID, course ID, right? A student, let's say course title, grade, and so on, right? And this is my composite primary key, right? And I said, okay, if course title only depends on course ID, which means we have partial dependency here, how do I normalize this table? This is a partial dependency, right? Course ID can uniquely identify course title. Get rid of the dependency. If you want to normalize your table, first, find your dependencies. 2, get rid of that. How do you get rid of that? Remove it from your table, okay? Put it in another table. So here is what we're doing here. So we want to get rid of this dependency between course title and course ID. So let's see how we do it. So you see here, now we removed this part from this part, right? So we store course information here or enrollment information so far here. And then we only have a student ID, course ID, and grade, right? Because grade has a full key dependency, so we have no problem. So what is the normal form of the green table? The one on the bottom left, this green one, the small tables. Is it in 1NF? Yes. Is it in 2NF? Yes. Although we have a composite primary key, we do not have partial dependency. We have only full key dependency here, which doesn't violate anything. Do we have transitive dependency? Yes. Do we have transitive dependency here in the table on the bottom left? Yes.
What if you have a derived attribute? Sorry, this is kind of, if you have a derived attribute, technically it relies on a different attribute.
Do we have to run that?
Not here.
It depends, case by case. I don't know what you're talking about now, right? If you have, for example, and I don't know those two columns, whether one of them is a primary key or not, is it like two non-keys? So let's focus on this example, okay? So is this 2NF? Yes, no partial dependency. Is it 3NF? Yes, no transitive dependency. Now here this one, is it 1NF? Yes. Everyone, please.
I believe.
Yes, yes. 2NF? Is it 2NF? What is the primary key? You have to like answer this in 1 second. So what is the primary key? The one, the red table. Course ID. Is it a composite primary key?
No.
If it's single primary key, then you don't have partial dependency. So there is no way with a single primary key coming up with some fictional partial dependency. So that is not possible, right? So is it in 3NF?
No.
Who said yes?
No.
No, it's not in 3NF, right? Sorry, it is not in 3NF. Why? Transitive dependency. Now, the table should be in 3NF if it is already in 2NF, which this table was, and there is no transitive dependency. Transitive dependency is the dependency between two non-key columns, right? Non-primary. Now, instructor location depends on instructor name, right? Can I say we have this dependency in this table? Can I write instructor name, instructor office or location? Yes, this is a dependency because if I tell you, let's say Mona, you have to know where my office is, right? Where my location is. So there is a dependency. What is the type of dependency? Instructor name is not a primary key, so this cannot be a full key, this cannot be partial, right? This is a transitive dependency. Now I want to go quickly to, so I already explained third normal form, and this just explained, for example, if you have a table, let me answer at the end because we don't have time. So we have a table in third normal form, okay, like this. So we have, for example, A as primary key. So A is your column with as a primary key. For example, a student ID, right? And then you have some columns here. Now let's say C and D are instructor ID and location, right? So there is a transitive dependency between C and D. Now you want to normalize this table. How do you do that? Find the dependency, get rid of the dependency, right? You find the dependency, you got rid of this dependency, right? You put it in a separate table. Now you have one table with C and D and then A, B, C. Now, this is the table that we were discussing a few slides ago, right? The one on top, we have course ID, course title, instructor name, location. The one I asked you whether it is in 2NF or not. So is it in 2NF? Like 2 seconds, please. Yes, yes, 2NF. It's single primary key 2NF, right? If I play Kahoot next session for like these questions, I give you like 5, 3. Honestly, I don't know what is the minimum. Like this is a single primary key, so no partial dependency 2NF. How many seconds? 2 seconds. So is it in 3NF? No, because we have transitive dependency. How to get rid of it? We showed, right? Get rid of the dependency. So get rid of this part. Put it in a separate. Now, if you also look at it conceptually from like the ER perspective, you are putting things like in separate tables, putting like each entity in a separate table, right? So even from like the conceptual part, it makes sense. Now you have instructor information in instructor table, you have course information in course table. Why do we have instructor name here? And this is, okay, I apologize for instructor name instead of instructor ID. In practice, we should have instructor ID here. I didn't have enough space to fit all that. So let's say instructor name is the primary. So what does the instructor name work? What does it do here in the course table? Yes? Foreign, right? Because these tables are related, right? We want to know who is the instructor of the specific course. So this is what I explained. So we have to first check if the table is in 1NF. If not, we have to get rid of those repeated groups or multiple values stored in one cell. Now, then we have to check if the table is in 2NF, which means it is in 1NF, and we have no partial dependency. For partial dependency, you always check primary, right? If it is a single primary key, 2 seconds, no partial dependency, right? If it is a composite primary key, then I give you like 10 seconds. You have to search. If it's a composite primary key, let's say we have a table, a student ID, course ID, grade. So if this is my enrollment table and this is my composite primary key, this is a 3NF, right? Because we have composite primary key, but we do not have partial dependency. So this is an example of having a composite primary key, but not having partial dependency. Here you have an example of having composite primary key and also a partial dependency. Now, with this example, what is the normal form of this one? And this is only one name. Okay, so this is internal medicine, this is Baker, so on. So, is this table in 1NF? Yes, we do not have multiple values in one cell. What do you think about primary key of this table? What should be the primary key here?
Patient code.
Sorry, what?
Patient code.
Patient code. So let's say, for example, we have one patient, right? Visiting several times, doing several treatment and procedures. So the patient code will be repeated in this table, right?
Sorry.
No worries. So the patient code cannot be a primary. So this table, with whatever column that you think of, they are all repeated. So if you want to like have doctor name or ID as the primary key, doesn't work because one doctor can visit multiple patients, right? Now each patient can go to like different doctors doing different procedures. So patient code will also be repeated. Procedure, of course, will be repeated. Date will be repeated. So no primary key in this table, right? How about composite primary? Yeah, the one with the hat.
Oh, we see that this is a 1NF.
Yes, this is a 1NF because
But
this
is there
is
one-
one name. This is only one name I mentioned. So this is one name, internal medicine is one name. So we don't have multiple values.
For 3NF, can we say if we don't have a foreign key in a table, then it is in 3NF after passing it to NF? So like the example that you mentioned, student ID, course ID, and grade, if you don't have any foreign key over there, it's already in 2NF, then it can
No,
be
we may
3NF.
have like something like instructor name and then name may not be. We also have instructor ID and name not as a foreign key, right? Because instructor ID is a foreign key, but we still have the dependency.
Because you mentioned it has to be an ID in the previous table that you had, for example.
No,
it doesn't
I
have to
mentioned
be.
for the full key
For the full
dependency, because the name says full key, right? It means that you have a column that depends on the whole primary key, right? So if you want to find a composite primary key here, it will be really inefficient. You have to find a combination of doctor, date, and code, and even maybe procedure, because if let's say one patient and at a specific date with a specific doctor, let's do several procedures, then we have to think about like several columns serving as composite primary. And that is not the best form of primary key here, because we have like these. If you have something like a student ID, course ID for composite primary key, works well. Why? Student ID is numerical, like it's integer. Course ID is integer, right? They are both short columns and they fit with like the hash defining them as primary. But here is one example of where you end up with defining surrogate key, right? A surrogate key, what is surrogate key? Just the primary key, yeah.
Already too late. Already too late in the database.
Yeah, this is a primary key that we introduce, or sometimes like it's auto generated by the system. So it wants to guarantee that it is unique. So for this example, I want you to like you can see we do the same procedure. So we add a surrogate key, which is visit ID here, right? And then we break it down into two tables. So we are normalizing these tables. So the first thing that we did was putting the procedure in a separate table and having it in our main table. And visit ID is just a surrogate key that we introduced. I will answer at the end. And then, so now from this table, we have also dependencies, right? We have dependency between doctor name and specialty, right? What type of dependency is this one?
Which one?
The dependency between doctor name and specialty. Transitive, right? Because it's not a full key, because doctor name is not primary key. We cannot have partial dependency because we introduce surrogate key and primary key is a single column. So there is no chance of partial dependency in this table. This table is in 1NF and is in 2NF, right? So the table we say is in 2NF. But is it 3NF? No, because we have several transitive dependencies. How do you normalize this table? You find the dependencies, like for example, giving you a doctor name, you can tell me what the specialty is, right? So there is a dependency between doctor name and specialty. This is how you identify dependencies. So if I tell you Dr. Davis, you know that what is his specialty. If I give you a patient code, write this code, you can tell me what the patient name is. So patient code can also uniquely identify patient name, similar to student ID, student name, course ID, course name, right? So these two are transitive dependencies. Before looking at the next slide, how do you normalize this table? Yeah?
You remove the specialty and the patient name.
Getting rid of the dependencies, right? So we have to put them where you find those dependencies, put them in separate tables. So look at these dependencies here and then the next table, right? So now we put the doctor and patient. So this is the doctor, this is the patient. So these two dependencies into separate tables. Now our visit table remains with only visit ID, doctor name, date, and patient code. Now all these three tables are in 3NF, right? Because first of all, they are 1NF, we have all atomic values. They are all in 2NF because they all have single primary key, right? We do not have, we cannot have partial dependency. And we do not have also transitive dependency, so it is in 3NF. So you do like this for like normalizing any table. Next session, we'll do a couple. I will open a quiz also for the normalization. It's optional, you can do it. Do you have any questions? No?